Good morning, Tehmina Khan is here in TKMaths S1. In today's video, I will explain to you a challenging question of simultaneous equation. It has been taken from CAIE past paper, November 17 variant 22 and November 18 variant 22. This simultaneous equation is a part of the syllabus of O-level additional mathematics. The question I've taken is simultaneous equation in logarithmic equation and in exponential equation, right? It's not simple polynomial. And before we begin, you can see on the top my website address tkmaths.com and my blog address tkmaths1.blogspot.com. Do visit it. You will find it very useful, I'm sure. I'm offering online help also on my website, and there are many free videos and other information which will be useful for you. So let's begin with the question. So first question solves simultaneous equation, and the equations are given in the logarithmic equation. So log is involved in it. So before you solve this, you need to recall few concepts. What are those concepts? Whenever we change log form into index form, so if it is log of x base a equals to y, then in the index form it will be x equals to a power y. So you must know how to change log form into index form. And then log of the exponential number, like log of x power r equals base a, will be equals to r multiplied by log of x base a. So this power go here as a multiplier. So remember these two rules. Now let's see. So first of all, I'm taking this equation, right? And in this equation, this 2 can go up here. So power law you can apply, and it will become log y square base 2. Okay. So this 2 will go up here as a power. Now what is the advantage of doing this? I have only one term on each side of the equals to. One term here, one term here. So if I'm saying log base 2 of this number is equals to log base 2 of this, they're equal. So we can remove log and it will become x plus 4 equals to y square. So you got one equation from this logarithmic function. So now logarithmic equation number 2. So if you see here, I will apply this concept and change this log form into index form. So right now, whatever my x is here, it is 7y minus x. So before I show you, can you tell me what it will become if you apply this concept? So see, your x here is 7y minus x, base a is 2, and y is your 4. If you compare this equation with this equation, so it will become 7y minus x is equals to 2 power 4. So now further simplify it and you will get 7y minus 16 equals to x. I have taken this x to this side. 2 power 4 is 16. I have brought it to this side. So now I have two equations and I will solve them simultaneously. So here are those two equations, and now you know how to solve simultaneously by substitution method. This value of x I will plug in here, right? I have shown you in black. So this value I'm plugging in here, and then it will become quadratic equation of y. And then you know how to solve quadratic equation, either factorization or quadratic formula or completing square method, whatever you like. So now simple factorization, and I ended up at y minus 4 and y minus 3 equals to 0. So now from this factorization, you got the values of y, and now you have to find the values of x. So the two equations, you can use any equation. I'm using this one. I will plug in this value of y here, and I will get the value of x. So you can see here, slowly I'm showing it to you. When y is 4, then what x will be, and when y is 3, then what x will be. So at the end, I got when x is 12, y is 4, when x is 15, y is 3. Now, why did I write checking here? Actually, when we get the values of x or y or the variables, we always see by plugging in these values in the log equation, because we know log is not defined for negative number. So if you see x12 y4, x12 here, it will remain plus, y4 is already plus, so this equation is fine. If you put y4, 7 4s are 28, minus your x is 12, so this will remain plus, so it's fine. So this answer is fine. Similarly, you will check for this. When x is 15 and y is 3, plugging in here, x15, it will remain plus, y3, it is plus, so log is defined. Similarly, if I put y3 here, 7 3s are 21, minus 15, if I plug in this value, so this will remain plus. So it means both these values are satisfying, so this is my answer. So always check your answer when you are solving log equations, right? Now let's see the second question, in which the exponential equations are given to you, right? Now when you are solving exponential equation and solve simultaneously, mean you have to find the value of p and q. So remember this rule. When you have, for example, a power n equals to a power m, base is same, so it means this implies power are equals to each other. So remember this rule. And second rule is, if index number is divided by another index number, then powers will be subtracted. So let's see. So I will simplify this equation and this equation side by side. See here. What I have done here, let's look at this first. I'm changing 8 to base 2. 2 power 3 is 8. P plus 1 I'm writing as it is. 4. 2 power 2 is 4. Q I'm writing as it is. And this is 2 power 11. So I have changed this whole exponential equation into base 2. Similarly, this one I will change into base 3. This is fine, writing as it is. 27 is actually 3 power 3. Can you notice? And this 1 over 3 as it is. 9 is 2 power 2, 3 power 2. And this 3q power is as it is, right? So I have changed this exponential equation into base 3. Now let's apply index rule here. So for example, in this case first, let's see here. If this 3 multiplied by 1 over 3, it will become 1. So 3 power 1. And then there is division sign. So powers will be subtracted. So 2p plus 5 minus 1, like I have shown you here. And this is 3 2s are 6q. Now when you have same base on both sides of the equal to, then you can equate the power. Agreed? So I have equated the powers here. I got one equation in terms of p and q. Now if you see here, this is 3p plus 3, right? Now division and 2 power 2q. So I'm applying this rule and I will subtract the power. So I'm writing 3p plus 3 minus 2q, right? This power minus this power is equals to 2 power 11. So again, base is same, so I will equate the powers. So I'm applying this rule now. So I will get another equation. So I got two equations and I will solve them simultaneously now. So these are the two equations. So it's up to you. You solve simultaneous, substitution method or elimination, whatever you like. I have solved here using substitution method. So I'm picking up this equation and bringing 3 here, right? And 2q also here. And I will make p a subject. Can you see? So this is the value of p, which I have gotten from this equation. Now this value of p, I will plug in here. So it will be 2 multiplied by this whole thing. Okay? See here. Plus 4 plus 6q. And I will simplify it. I am multiplying 2 by this. By the way, sometimes a student make mistake. and multiply 2 by the denominator as well. So do not make this mistake. 2 will only multiply by the numerator. After that, I will take, you know what, LCM, and then I will cross multiply. So now I have taken LCM here, 3 4s are 12, and then I'm doing cross multiplication. Okay, so after cross multiplication, I'm simplifying it to get the value of Q. Once you got the value of Q, you have two equations. Any equation you can use to find the value of P. I'm using this equation. We have two equations earlier. So I will substitute this value of Q here, and I will get the value of P. So this is how you will get the value of P and Q. So in that, so at this, the equation is solved. We got the values. Thank you very much for watching this video. If you learned something from this video, or if you liked it, please press like and subscribe button. Give your encouraging comments, and please do share it with your friends. Thank you very much. Once again, take care. Allah Hafiz.